Hey physics, Tyler here. There's an easy way to increase your speed when rolling a car down a hill. All you have to do is change the size of the wheels. Having smaller wheels results in a larger acceleration, but a slower top speed. And having larger wheels results in the opposite. But why? To figure this out, all we have to do is change the size of wheels on a car.
We'll use a 3.05 meter ramp and drive a car with 3 different wheel sizes down, starting from rest, checking the speed of each cart as it reaches the end. With the 2.5 millimeter radius wheels, we can see that the car slows down, but speeds up throughout the drive, ending with a speed of 0.58 meters per second. This is because the larger radius of the wheels gives it a larger moment of inertia, meaning that with the same torque, its angular acceleration, and by extension its translational acceleration and velocity, will be smaller.
So, let's just shrink the wheels then, and it'll be faster, right? No.
When we look at wheels with a radius of 1 millimeter, we see that the car actually ends up with a smaller final speed of 0.48 meters per second. If we look at this car, we see that it reaches its maximum speed quite quickly, and then stops accelerating. This is because it's reached its terminal velocity. The wheels won't turn any faster because of air resistance and a maximum force of friction with the ground, and due to the small radius, the translational velocity from the rotation will be smaller.
So how do we find the perfect wheel size? Well, we need a wheel size that's big enough to not have such a small top speed, and that's small enough to not have such a slow acceleration and such a large moment of inertia. And we find this at about 1.45 millimeters in radius.
As the 1.45 millimeter wheel goes down, we see its speed ends up being 0.72 meters per second. Here, the moment of inertia is just small enough that it will accelerate quickly, and just large enough to not stop accelerating early, showing how the wheels on a car are neither helped by being too big or too small. There's a sweet spot in finding the perfect size for maximum speed in going down a hill.
As with any experiment, there's going to be an element of human error. This human error occurred in the timing where the experimenters would have stopped the stopwatch too early or too late from when the car actually reached the bottom of the driveway. But it also may have occurred due to the fact we don't know the coefficients of kinetic friction between the driveway and the wheels, and the different coefficients of kinetic friction between the different materials we use for the wheels, as 3D printing the wheels had a different material than the store-bought ones. However, this should leave the experiment unaffected.
Thanks for watching. Hey physics, Tyler here. If you want to increase your speed when going down a hill on a car, all you have to do is wheel size changes. Yeah, that's right. Hey physics, Tyler here. If you want to increase your speed when rolling down a hill in a car, all you have to do is something that I forgot. What is it? Hey physics, Tyler here. What's my line? So let's just shrink the wheels then. It'll work, right?